Welcome to the second video, and should be the last video for P5. In this video, all we're going to do is exercises. We shouldn't really need the PowerPoint for anything, so I'm just going to go straight in. The first type of exercise we're going to look at in this section is additions and subtractions of polynomials. That'll be these first two exercises right here. And if you've done any algebra before, these will probably be pretty familiar to you because all we're going to be doing is just collecting like terms. So in exercise 15 here from P5, all you do to subtract two polynomials is make sure you distribute this negative through the second polynomial here. So minus x squared plus 8x minus 3. And this one I can just drop the parentheses because it has a positive in front of it. And now just collect like terms. So I've got 2x squared and x squared. That'll get me a single x squared. I've got a minus 5x and a plus 8x. So that'll get me a plus 3x. And then I've got a minus 3. And that's it. Here, even simpler. There's no minus, so you don't have to distribute the minus through the parentheses. Just drop the parentheses and add. So I'm just going to ignore the parentheses and combine like terms. So x squared and 3x squared gets you 4x squared. 10x minus 12x would give me minus 2x. And negative 3 plus 5, yeah, it'd be positive 2. So that's addition and subtraction. I honestly don't expect you guys will have too much trouble with it, just because it's something you've likely already seen many times before. Multiplication you've probably seen as well. Here I'm taking a monomial times a trinomial, a single-term polynomial times a three-term polynomial. And all we got to do here, you might have already guessed, is just distribute through. So I'll write the intermediate steps here, but you don't have to when you're doing your own work. 3x cubed times x to the fourth minus 3x cubed times 4x squared plus 3x cubed times 5. And then you can see x cubed times x to the fourth. Remember, if you're multiplying two expressions that have the same base, you add their exponents. So this will just be x to the 7th minus 12 x to the 5th plus 15 x to the 3rd. And that's it. For the multiplication of a binomial times a binomial, I'll probably look at several different ways of doing this problem. The basic idea behind multiplying binomials is really the same idea as up here. Here we took this polynomial 3x cubed and we distributed it through this parentheses, through this other polynomial. Really that's what I'm going to do here. I'm going to take this polynomial here, 4s minus 1, and I'm going to distribute it through the second one. 4s minus 1 times 2s and 4s minus 1 times 5. Don't really need that parentheses there. When you multiply that out, you will get 8s squared minus 2s plus 20s minus 5. And then you can combine the like terms in the middle, and you get 8s squared plus 18s minus 5. Thing is, you could get all of these same four terms by just starting in one parentheses and taking all of your terms times all of the terms in the other parentheses. So take 4s times 2s, you get the 8s squared. 4s times 5, you get the 20s. Take your negative 1 times the 2s, you get the negative 2s. Negative 1 times the 5, you get negative 5. That's where you may have heard the term before, FOIL, when you're talking about these types of multiplications, binomials times binomials. That stands for first plural, outers, inners, and last. And this is just really a checklist to make sure you've got all the terms when you're multiplying two binomials. Because you have the firsts, which is the 4s and the 2s multiplied, because the 8s squared. You have the outers, the 4s times the 5, that gets us the 20s. You have the negative 1 times the 2s, which gets you negative 2s. And you have the negative 1, that's the inners, because it's the two ones that are closest to each other in the inside. And then the last would be the negative 1 and the 5, because you take negative 1 times positive 5, you get negative 5. That's fine to use as a term. I kind of object to using it as a verb when I say, I don't usually say FOIL out because, well, we're going to be doing lots of different multiplications of polynomials, and FOIL really only applies to binomials, and we'll be doing all kinds of multiplications. But you can say whatever you want. I'll probably understand it. So let's see here. We multiplied out. We got that. The only other thing I might say about this problem is some people like to organize these in a box, and that's perfectly fine to do it. It's a box or a table. So the way you multiply polynomials, this will work for any kind of polynomial, on a table is you put one of your polynomials on the rows and one on the columns. So 4s minus 1, and I have 2s plus 5. Then you fill in the table with the multiplications of the row header and column header. So 4s times 2s, 8s squared. 2s times negative 1, negative 2s. 5 times 4s, 20s. And 5 times negative 1, negative 5. And there you go. Some people like to use that, and then the nice thing is that the like terms are often on diagonals, or at least in some pattern where you can see them. I don't honestly do this box or table approach that much when I'm dealing with binomials, because I mean there's only 4 terms to keep track of. But when you get up to multiplying a 3-term polynomial times a 3-term polynomial, and you end up with 9 terms, you can see why it might be handy. Now we have exercise 52, where we have 2 plus y cubed squared. Now this is not remarkably different from the previous problem. I mainly wanted to do this problem just I just wanted to point out a common error my students make so that you might avoid it. And the thing to remember is that exponents do not distribute across an addition or a subtraction. This is not equal 2 squared plus y cubed squared. Both of those terms will appear in my final answer, but there are other terms as well. So that is not the result. Because if you think about this, squaring something, that means multiplying it by itself. And that is a binomial times a binomial. So we're going to multiply it like one. 2 times 2, the first, you get 4. 2 times y cubed, we get 2y cubed. Y cubed times 2, the inners. we get 2y cubed. The last, y cubed times y cubed, we will get y to the 6th. And then we can combine like terms, have our 2y cubed and 2y cubed together. They will get us 4y cubed, and we still have that y to the 6th. 56 is along the same lines as well, although this will illustrate a nice property of certain types of multiplications. The way it works: 2y plus 5 times 2y minus 5. You can just multiply it out like we have been doing. 2y times 2y, 4y squared. 2y times minus 5, negative 10y. 5 times 2y, plus 10y. 5 times negative 5. Now notice what happens with the cross terms here. The negative 10y and the 10y subtract and go away. So all you're left with is 4y squared minus 25. This actually leads to a very famous multiplication or factoring formula, which says if you have a plus b times a minus b, that is always just going to equal a squared minus b squared. So if you have the same terms added and subtracted in different binomials, you can just skip to the end. We knew it was going to be 4y squared, because if you square this, you get 4y squared minus 25, the square of 5. In any case, it doesn't take very long. It's just a quick formula for multiplication. It's actually more helpful going the reverse direction when we use it as a factoring formula. And we'll see that in the next section. Here I have a cube, and I'll again remind you, this is not equal 1 to the third minus 2r to the third. Exponents do not distribute across an addition or a subtraction. They do distribute across a multiplication or division, but not an addition or a subtraction. Again, these terms will appear in our answer, but we'll have a bunch of other terms. In fact, this will be probably the hardest multiplication we've done yet. There's what 1 minus 2r cubed is. So how are we going to do this? Well, we're just going to multiply these things one at a time. I'll multiply 2 of them together, and then multiply the result times the 1 minus 2r I have left. So I do my binomial work on these. 1 times 1 will give me 1. 1 times minus 2r will give me minus 2r. Minus 2r times 1, minus 2r. And minus 2r times minus 2r will be plus 4r squared. Simplify that one more step. I have 1 minus 4r plus 4r squared. I'm multiplying that by 1 minus 2r. Here's our first trinomial times a binomial. This one I will get 6 terms, because you start from here, multiply it through, start from here, multiply it through. You can set it up in a table if you want. I'd probably set up my table like this. 1 minus 4r plus 4r squared. And then 1 minus 2r. So just filling in the pieces. This would be 1, negative 4r. 1 times 4r squared is 4r squared. Negative 2r times 1. Negative 2r times negative 4r will give you 8r squared. And then negative 2r times 4r squared will give me minus 8r cubed. And you can see the nice thing about this setup, I have diagonals that have like terms. 4r squared, 8r squared, negative 4r, negative 2r. But the way I generally do these is I just go systematically and I just indent a line after I finish with one of my terms over here. So 1 times 1 is 1. 1 times minus 2r is minus 2r. And then I just indent a line and go down 1. So negative 4r times 1 is minus 4r. Negative 4r times negative 2r is plus 8r squared. Then 4r squared times 1 is 4r squared. 4r squared times minus 2r will be minus 8r cubed. Then adding the like terms together, we'll get 1 minus 6r plus 12r squared minus 8r cubed. And I do believe that's the same thing I would have got from the table. Indeed. The last problem I'm going to do in this lesson is actually one I made up myself, so the 3008 is just me being silly. It is just a trinomial times a trinomial. It'll be very similar to the last one. I'm just going to multiply it like I did at the end on the last one. Again, you can set up a table with 3x squared minus 7x plus 8 and 5x squared plus 4x minus 9. This is going to have quite a few terms. Because we have a 3 times a 3, we are going to end up having 9 terms. So it will be quite a few. Multiply the 3x squared through, I will get 15x to the 4th plus 12x cubed minus 27x squared. Now I move to the 7x. That's really why I go down a line. It's hard to remember quite where you are in the multiplication if you don't have some milestones there. Negative 7x times 5x squared. Negative 7x times 5x squared will get me negative 35x cubed. Negative 7x times 4x will be minus 28x. Negative 7x times negative 9, 28x squared I should say. Negative 7x times negative 9 will be plus 63x. Multiplying the 8 through, we will get 8 times 5 is 40x squared. 8 times 4 will be 32x. And then 8 times 9 will be minus 72. Combining like terms, 15x to the 4th. That will be minus 23x cubed. That's 55, so add 40, that'll be negative 15x squared. That would be 95 plus 95x minus 72. And there we go. I hope you found that helpful. We'll come back next with P6, where we talk about literally the opposite of multiplying polynomials, factoring polynomials. I'll talk to you then.